I'm going to be talking about precision agriculture, and certainly if there's a win-win situation with respect to many of our stakeholders, this is one of those. Having more efficient nitrogen use by our agricultural systems has payback from the standpoint of economics that the farmers see, as well as from the standpoint of environmental issues such as nitrous oxide release from those systems. And as we become more efficient with our nitrogen use, that certainly translates into benefits for many. So from that standpoint, you can see a little picture of the Palouse area here. The soils and the landscapes create this circumstance where there are very different kinds of environmental conditions across these lands. And from that standpoint, if we look at the precision ag triangle, there's application technology, field diagnostics, and those kind of link back and are resting on this decision support system. And for the project, the REACCH project, as well as a large collaboration with a site-specific climate-friendly farming project headed up by Dave Brown, we're primarily focusing on the field diagnostics as well as the decision support systems. So this is a typical pattern that you might see for the 92-acre Cook farm, and you can see this is relative yield. The lighter areas are low-yielding areas relative to these darker areas, which are high-yielding areas. And the yield is almost 2.5-fold across these landscapes. And this is pretty common across the fields that we see. And I tell the growers to follow the water, because water is a major driver from the standpoint of why we're seeing these different kinds of yield potentials across the landscape. This is the patterns of water in the soil profile in the spring, and you can see some of the same kinds of patterns: low water amounts, lighter, higher water amounts, darker. It's good to have Aaron Brooks on board from the standpoint of understanding hydrology from a landscape perspective, and this is a model from his soil moisture routing model, and I was actually shocked at how well this looked from the standpoint of water distributions across this field and what I typically see in this particular field. And certainly from the standpoint of the expressions of differences in water across the landscape, we see that in our crops every year. And so you see these patterns where the dry areas are senescing much more early, they're running out of water, and the green areas are locations where there's more water, and these translate directly into differences from the standpoint of the productivity of those areas. So you can already imagine, okay, if I'm using remote sensing to try to assess some of these patterns, that's going to be valuable from the standpoint of defining different kinds of zones. And I already alluded to some of the different kinds of crop management zones that we're trying to devise for growers, and one exercise that we're currently going through now is looking at early adopters in terms of precision ag. We're meeting with them. We're going through their decision-making process to see where the knowledge gaps are from the standpoint of precision ag and how we can bring our science to bear to try to help them devise economically and environmentally sound zones. So a lot of discussion about zones, what constitutes the zones, their location as well as their stability through time, and how we might bring, again, our science to bear on that. This is some of the remote sensing efforts that are headed up by Lee Veerling and his group, Troy Magny here, and Jan Idle are two others that are working in this area. And here we see the gecko. It has two laser wavelengths, a green and a red band, and those tend to be able to assess some of the early plant nitrogen status. We're trying to link that into, again, some of the decision support. And over here we see some of the use of rapid eye imagery. This is satellite imagery. It's about a 5 to 6 meter resolution, and you can see distinct patterns across this particular field that are, again, related to some of the senescence patterns that we're seeing. So we're trying to, again, use these kinds of tools to be able to define different management zones that are useful for growers in order to make better decisions regarding their nitrogen applications. And of course, a lot of this links back in, hopefully, to some of the modeling efforts. We're talking about nitrogen, but certainly when we go through and look at this from a crop model perspective, we can bring to bear the other factors that we're also interested in from the standpoint of changes in soil organic carbon, greenhouse gas emissions, et cetera. Hopefully, the water, nitrogen, carbon balance all links into this from the standpoint of what's happening across the different kinds of environmental and landscape situations in our fields. And definitely integration with economic and crop modeling efforts is extremely important here. And consequently, integration steps include linkage of field precision ag research to modeling and modeling efforts. And I think biotic factors was brought up earlier today as well. These are certainly factors that we see also in these landscapes that are impacting some of the differences in productivity that we see in these fields. Linkages to regional surveys regarding assessment of precision ag and practice adoption. It's very interesting to see the results of some of the surveys, or will be, from the standpoint of who's doing what some of the early adopters are doing from the standpoint of precision ag and what their thoughts are about that. And again, I mentioned the integration with other projects. This is just an example of some data from the Site-Specific Climate-Friendly Farming project, where we're looking at manipulating both plant density and nitrogen use, because both of those factors are regulating the use of water over the course of the season, and that translates then into differences in nitrogen use efficiency. As well as demonstration plots. These ones out at St. John, looking at various strips of different kinds of treatments across the landscape that are influential. In this case, interestingly enough, reductions of seeding by over 50% resulted in similar yields and actually better nitrogen use efficiency overall from the standpoint of the crops there. And with that, I'm wrapped up. Thank you.